Vostok has been hidden underneath 4 kilometres of ice for tens of millions of years. Scientists want to reach it in order to find out more about the climate of the past and of the future. They also want to find out whether the lake contains any forms of microbial life. In 2012, after decades of trying, a Russian team drilled through to Lake Vostok. Vostok is widely regarded as one of the most exciting scientific projects in the world today, and the breakthrough was met with great excitement. Right now, the short summer in Antarctica has come to an end, and Russian scientists have just flown out of the Vostok station before the weather makes them prisoners there. Just before he left, glaciologist Dr. Vladimir Lipinkov talked to me over satellite phone from the Vostok station. I began by asking Dr. Lipinkov whether he and his colleagues had penetrated the lake once again during the 2-month Antarctic summer.
No, we did not, and there was not such a plan to penetrate into the lake during this season. The plan was to drill as deep as possible, because the season is just 2 months long, and to get closer to the lake again to prepare the second unsealing during the next season. That's what we did, and I think it was a successful season.
Since the season is so short, scientists there work very intensively. Dr. Lipinkov.
We are 12 people, 2 of them are glaciologists and the rest are drillers. So the drilling is continuing 24 hours day and night, and the glaciologists take care about the ice core, some processing the ice core in order to obtain samples and specimens for further studies in laboratories. That's our main and rather routine task for this season.
So what's Dr. Lipinkov's day been like so far?
We got up at 8 o'clock. We had some breakfast. We need to eat well, because otherwise you will not be able to walk in the cold. Then we start to walk. We start logging the ice core, which was obtained during the night. And then we are 2 people, and we have 2 glaciological labs here. So one was working with a new ice core, making some samples, and another was working with an old collection of ice cores, making some thin sections for texture and fabric study of ice. Thin section, it's just thin section of ice. You put it on the polarized light and you can see the ice structure. So now we are 4:15 p.m. and we are preparing to get another ice core, because, as I told you, drilling continues without stop. So we are going to get back to the drill and to get new ice, and then again we will be working in the labs. We will stop at 11 p.m. and then we'll go to the bed.
Do you stop to eat in between?
Yes, of course. We have a lunch and we have a dinner at 7 p.m. Of course we have something else except the breakfast.
I asked Dr. Lipinkov whether the team was tired after working for 2 months solid.
Oh, a little bit, but as usually it's not our first season at Vostok. It's normal season at Vostok without weekends and holidays, and because we have many things to do and we would like to do as much as possible, and the time is short. We're trying to do as much as possible every day, that's true.
Despite the difficult conditions, however, scientists who work at Vostok tend to be attached to the place. I asked Dr. Lipinkov whether he'd really prefer to be at Vostok station right now over anywhere else in the world.
Yes, of course. We know that we should be retrograded from Vostok on 3rd and 5th of February, and we would like that it will be later than this, because in this case we would have more time to work here, because it's short time really. You should take opportunity to get more data, more information, more samples while you are staying at Vostok.
Will he be sad to leave?
I will not be sad to leave. I will be happy to leave and to switch for another life, but until we are here, we take this opportunity to work.
I then had a chance to speak to the other glaciologist on the team, Dr. Alexei Yekaikin. Besides his many tasks at the Vostok station, Dr. Yekaikin also tried a new bit of research during this season, something involving what's known as a skidoo, or a snowmobile, and megadunes.
Megadune is just the name of some special features of snow and ice relief in Antarctica. It's huge waves as long as 2 or 3 kilometers and few meters high. It's not exactly known why they are formed in certain places. So we have mega dunes not far from Vostok, like 30 kilometers, and we had a small scientific traverse by Skidoo to study these mega dunes, and this was very quite new and interesting for me.
Meanwhile, in the UK, British scientists are working on new ways to drill through to Lake Ellsworth in West Antarctica, which is also buried under several kilometres of ice. A British team led by Professor Martin Siegert of Bristol University spent several years designing a hot water drill that would penetrate the lake without harming the environment. But on Christmas Day 2012, they had to stop drilling due to technical problems. Professor Siegert.
So we were trying to get from the ice sheet surface down 3 kilometres into a subglacial lake underneath it. Because we're using hot water drilling, which is melting ice, we needed to create a lot of water. And so the technique we were using is to establish a reservoir of water 300 metres beneath the surface. Our experiment in Antarctica stopped when we failed to achieve the link between the main hose and the cavity.
Isn't it true that you were madly shoveling snow with your team to try and add water in, but it didn't work?
Yeah, the issue is once you get down to below about 100 or so metres in the Antarctic ice sheet, it's very solid glacier ice, so it's impermeable. And so in order to recirculate the water, we needed to make that cavity. Now, unless you do that, then what happens is you're simply losing water into the impermeable layer at the top of the ice sheet. Unfortunately, we ran out of water and we couldn't keep up with the supply. So it was just sort of frantic few hours in which we really tried to keep the water levels as best we could. But, it was a losing battle in the end. We were becoming more and more tired and exhausted as the demand for water retained at the same sort of level. So we were trying for 40 hours. And so we had initially budgeted for about 12 hours of this, and we thought that was fine. We had a sort of contingency for double that. But we were well outside of that contingency phase. So we really tried our best to make that cavity. And in the end, we couldn't do it.
The failed attempt to penetrate Lake Ellsworth came after years of preparation. Though disappointing, it wasn't a complete surprise. Professor Siegert again.
Well, I've been working on subglacial lakes research since 1996, since the mid-90s, but in this particular project for about 10 years or so. So we were setting up the sort of scientific reasons to do it. We were looking at the geophysical background for the work, and so understanding the physical shape of the lake. But the actual experiment itself took about 5 years to plan and coordinate and set up.
So it must have been very disappointing.
Well, it's disappointing, and so there were a number of ways to look at it. Firstly, when you're doing work in the middle of Antarctica, it's rare that complex experiments like ours are 100% successful first time round. And so you have to understand that it's like a norm in Antarctica. We want to make sure that this is the first time our type of experiment has been done in Antarctica. It's still the only time it's been done, and what we've learned are some hard lessons.
Reading Siegert's diary from the time, it sounds as if some of the problems, like the boiler not working, were not expected and rather worrying.
In some ways, we didn't expect any of it to fail, but at the same time, we had a lot of contingency, we had a lot of spares, we had a lot of expertise in the engineering sense, and we were able to solve a lot of problems when we were there. Doing deep field Antarctic research, that's situation normal, right? That's what you have to expect, and we accommodated a lot of those. There were some issues, however, with the drilling procedure that we couldn't sort out, and our failure to link this cavity beneath ourselves was something that we weren't expecting to be as big a problem as it was, and that's something we simply couldn't solve in the field. And so what our job is now is to look at the drill and think about why that drill wasn't capable of successfully completing that part of the procedure, and what modifications we have to make to that drill to make sure that next time we do it, we will be successful.
Do you have some options for that already, or is it too early?
Yeah, we do have options, and it probably is too early for me to say precisely how we will solve it, because there's more than one way to do it. For example, a better way of linking the cavity is to fully understand the position of the drill heads as we're drilling down. We were assuming verticality of the drill heads. If they were vertical, we wouldn't have had a problem. We expect that our drills that we were drilling were slightly off vertical, and you don't have to be far off the vertical, over 300 metres, to be actually quite some distance away from those two holes.
And that can just happen quite easily?
It can happen easily if the drills are not behaving in the way that we expect them to. So it sounds like they didn't. Now, one way to reduce the risk is to make sure that those drills are hanging vertically, right? That's one way to do it, and there's various options available for us to do that. Another is to say, well, this linking of a cavity was such a critical moment, and its failure was a single point of failure, and the whole experiment is over when we couldn't do it. Another way is simply say, well, we'll just design an experiment where we don't need to do that next time. Now, that's easy to say, and of course there's a temptation to say, well, we'll just design an experiment where we don't need to link this cavity because it was such an important problem for us last time. But if we design or redesign the drilling procedure that way, there will be other issues that crop up as a consequence. And so these are the engineering decisions and discussions that we're having at the moment. We've completed our assessment of what went wrong. We've completed our assessment of why it went wrong. That's a lot of steps going backwards. What we have to do now is work out what the preferred way forwards is going to be. And that's our challenge for our next few months.
Scientific work in Antarctica is notoriously expensive. So I asked Martin Siegert to explain how he can secure funds for the next attempt to drill through to Lake Ellsworth.
Well, we know where we are, and there are funding routes available to us. So funding is based on science. There is science that we want to achieve here, and the science motivations for our project haven't changed. We hypothesise that subglacial lakes contain life, and there are interesting climate records on their sediments on the lake floors, and those hypotheses can be tested, but they just need direct measurements and samples of the environment done in an ultra clean way. And so that hasn't changed at all. The scientific drivers for our work remain as valid now as they did some years ago. It's just the drill needs to be done. So what we have to do is to put a proposal in which aims to redevelop the drill that we have in a way that allows us to conduct the research that we want to do. And so we pretty much know where we have to go with the proposals. There's no guarantees we're going to get funding, but as I said, the scientific reasons to do our work were serious and good enough to get funding last time, and they haven't changed.
I think perhaps people on the street don't really know where this money comes from, what possibilities there are.
Okay, so the research councils, the United Kingdom research councils, fund work in all areas of science. There is applied research that they have, but there is blue skies type of curiosity-driven frontiers research as well. And our research comes into that latter category. We're trying to develop things and do things in a way that no one has ever done before, and the successful missions are characterised by new discoveries and by development of new equipment as well, and new procedures and new techniques. And so getting this experiment right might well lead to lots of other experiments in other fields in Antarctica. Getting to the bed of the Antarctic ice sheet is interesting from a microbiological perspective, from a glacial history perspective, from a geological perspective, and all sorts of things. But we can't do it yet. And so what our successful mission in the years to come might well do is path the trail and the way forwards for other projects.
Dr. Lipinkov has now left the Vostok station and is on his way back to Russia. But others have stayed behind. A group of 12 men will live at Vostok for the year ahead to keep the station ticking over. There's little doubt that the winterers, as they are known, will miss those who became part of their community over the past 2 months. They'll live at the base as the Antarctic summer transforms into the bleakest of winters, a test of mental resilience as much as one of physical toughness. His colleagues had penetrated the lake once again during the 2-month Antarctic summer.
No, we did not, and there was not such a plan to penetrate into the lake during this season. The plan was to drill as deep as possible, because the season is just 2 months long, and to get closer to the lake again to prepare the second unsealing during the next season. That's what we did, and I think it was a successful season.
Since the season is so short, scientists there work very intensively. Dr. Lipinkov.
We are 12 people. 2 of them are glaciologists and the rest are drillers. So the drilling is continuing 24 hours day and night. And the glaciologists take care about the ice core, some processing the ice core in order to obtain samples and the specimen for further studies in laboratories. That's our main and rather routine task for this season.
So what's Dr. Lipinkov's day been like so far?
We got up at 8 o'clock. We had some breakfast. We need to eat well because otherwise you will not be able to walk in the cold. Then we start to walk. We start logging the ice core which was obtained during the night. And then we are two people and we have
Lake Vostok has been hidden underneath 4 kilometres of ice for tens of millions of years. Scientists want to reach it in order to find out more about the climate of the past and of the future. They also want to find out whether the lake contains any forms of microbial life. In 2012, after decades of trying, a Russian team drilled through to Lake Vostok. Vostok is widely regarded as one of the most exciting scientific projects in the world today, and the breakthrough was met with great excitement. Right now, the short summer in Antarctica has come to an end, and Russian scientists have just flown out of the Vostok station before the weather makes them prisoners there. Just before he left, glaciologist Dr. Vladimir Lipinkov talked to me over satellite phone from the Vostok station. I began by asking Dr. Lipinkov whether he and his